Hello, I hope you are all doing well. This is a rundown of Unit 2, Lesson 6, Subtract Fractions and Decimals. Now today I'm going to be focusing on fractions for the most part, but we'll run through just some reminders about working with decimals as well. Okay, so first off, there's a review of two different concepts that you've probably seen in the past. I hope you have, right? You've probably heard of them. One of them is the associative property of addition. So when adding three or more numbers, the way you group them with parentheses doesn't change the final answer, or known as sum, when we are adding. Okay? So I gave you a pretty simple example here. So we have 3 plus 5 in parentheses plus 6. So according to order of operations, right, we would add 3 plus 5 together first, which gives us 8. So 8 plus 6 gets us to 14. Over here, it's the exact same numbers in the same order, but I moved the parentheses. And so now, according to the order of operations, I would add 5 plus 6 together first, getting 11, and then 3 plus 11 still gets me to 14. So even though the parentheses moved, it didn't change my final answer. All right? Commutative property of addition, very similar, okay? But what the commutative property says is that the numbers can commute, or they can move from one spot to another. So 3 plus 5 plus 6 is the same thing as 6 plus 3 plus 5, okay? So again, that would get us 8 plus 6 is 14, or 9 plus 5 is 14, okay? So we can use those properties in order to help us even with subtraction of fractions and decimals. Because remember in the last couple units we talked about, or last couple lessons I should say, we talked about additive inverses and things like that and how they can help us with fractions and subtraction. Okay? So this first example is taken from your practice, which is on page 14 of your lesson. Okay? So on this one, we have 8 minus 7 1/4. Okay? So there's a couple different ways that you could go about doing this. You might recognize right away, well, let's see, 8 minus 7 is 1, right? But then we have to subtract a little bit more than that. So I mean, like, even if I were to break up the 7 1/4, we could say, well, 8 minus 7 equals 1. So now I have to do 1 minus 1/4. And you might be able to do that in your head, which I would absolutely love for you to do. Okay, hopefully you have that kind of recognition with fractions, but if not, that's okay. In order to subtract fractions, right, we have to have a common denominator. Well, 1, I could make that into a fraction by writing it as 4 over 4, or 4/4. Right, if I have 4 out of 4 pieces, I have 1 whole, right? So these are the same thing. And 4/4 minus 1/4 gets me to 3/4. So that's one way you could go about doing that. Okay? The other thing that we could do is we could convert both of these to improper fractions and go that route too. Well, let me rewrite the problem. So we've got 8 minus 7 1/4. Well, in order to write 8 as an improper fraction, I just put it over 1. Any whole number you can turn into a fraction by putting it over 1. Okay, it's like saying I have 8 of something in one group. Okay, and then 7 1/4, well, we're going to take our whole number, multiply it by our denominator. So 7 times 4 gets me to 28, plus 1, our numerator, gets me to 29. So we have 8 over 1 minus 29 over 4. Well, that's kind of gross looking, isn't it? But with that, I still have to have a common denominator. So I can turn a 1 denominator into a 4 by multiplying it by 4, right? 1 times 4 is 4. And then it would be a common denominator with this one. So I'll multiply by 4, but whatever I do to my denominator, I have to do to my numerator in order to keep it balanced. Okay? So now I have 4 times 8 is 32 over 4 minus 29 over 4. Whew, that looks a little better, right? Because now we have the common denominator. They're both in improper fractions. So now I can just subtract my numerators. Well, 32 minus 29 is 3, and I keep that same denominator, getting me to 3/4. So either way, I was able to get to 3/4. Okay? So, hopefully that helps. Again, that was I think it was number 1 from your practice on page 14. The second problem that we're going to do is number 3 from your practice on page 14. Okay? So with this one, remember using the additive inverse, right? So one thing that we could do is we could say, okay, well, I recognize that subtraction is the same thing as adding the inverse. So I could say this is like saying plus -4 1/3. And the videos in your lesson go over this and stuff, so hopefully that doesn't sound too foreign. All right. But then with that, let's see here. So now we can think, okay, they have the same sign, right? Which means we can just add them together and keep that same sign. All right, so that's one, that would be using the additive inverse, which we talked about in previous lessons. Okay, the other thing you can do is kind of think in terms of, I don't know, let's just say money. I know they're fractions, but let's just say it's money. Okay, and so with this one, we could say, okay, I borrowed $6 7/12 from my mom. All right, I borrowed it. That's why it's a negative, right? Because I don't have that. Okay, and then I borrowed another 4 1/3. So how much did I borrow in total, right? That means I need to combine them or add them together. But because I owe her that much, it's still going to be negative. Okay, so that's one way to kind of think of it in like a real world context to help the numbers make sense. Okay, so with this, whether you look at it like this or you look at it like this, we're combining them, and then our final answer is going to be negative. Okay, because they are both negative. All right, so let's see. First, we've got 2 things wrong. First off, right off the bat, I notice 1, they are both mixed numbers. 2, I don't have a common denominator. All right, so first I'm going to make a common denominator. Right now my denominators are 12 and 3. Okay, well, I know that I can multiply 3 times 4 to get to 12. So thankfully, this one can stay as a 12, but I'm going to convert that one to a 12 by multiplying by 4. So let me start out by just rewriting the whole thing. We got -6 and 7/12. Okay, plus, and then -4. Now when I'm making my common denominator, I don't have to do anything with the 4 yet. I'm only dealing with the fraction. I'm cutting my fraction into equal-sized pieces as this one. So in this case, I'm going to say, okay, well, I can multiply by 4, because whatever I do to my denominator, I have to do to my numerator. So I know my denominator is going to be 12, and then 1 times 4 is 4. Okay? So, from that, now I'm going to make both of them into improper fractions. Alright, these numbers are a little bigger than other ones that we've dealt with, but that's okay. We got this. You can always do work on the side if you need to. Well, we're going to take our whole number and multiply it by our denominator. 6 times 12 is 72. Then we add in our numerator, so we have that 72 in our brains, plus 7 gets me to 79, right? So negative 79 over 12 plus negative, and then 4 times 12 is 48, plus 4 gets me to 52, okay, over 12. Now remember, we're combining them, right? Remember that from earlier, we're combining them. And so really we need to know, well, what is 79 plus 52? I'm going to do that off to the side. My brain doesn't feel like doing that in its head right now. So 79 plus 52. 9 plus 2 is 11. Drop my 1. Carry my 10s. 1 plus 7 is 8. Plus 5 is 13. So that gets me to, remember my answer is negative, 131 over 12. Okay? You don't do anything with those denominators. They stay the same throughout. Okay? So, now I need to convert my answer to a mixed number. Okay? So, let's see here. What I need to do is I need to think to myself, well, how many times does 12 go into 131? There's a couple ways you can think about this. First off, using just good number sense, I can think to myself, well, 12 times 10 gets me to 120. Can I use any more than that? No, right? I would have to have 132 to use 11 12. So I can say my answer is negative 10. I used 10 12s to get up to 120, and then I have 11 left over to get to 131 out of 12. Then I can check, can it be reduced at all? No, 11 twelfths is reduced as it can be. Okay? So that will be your final answer on that one. Now this next problem that we're going to do, let me scoot my notebook up. And there we go. Hopefully that's okay. Okay, with this one, this is number 1 from your quick check. Okay, number 1 from your quick check. And it's going to help you with the next, let's see, it'll help you with number 2. Okay, on your quick check as well. I was just checking on my other screen. Okay, with this one, so remember how we talked a tiny bit about like the associative property of addition. We talked about commutative property of addition and different things like that, right? So I can actually kind of like break these numbers up, right? If I break this up, would it be fair to say for me to say 12 plus 8/15? Isn't that the same thing as 12 and 8/15? Right? Right now I'm just adding them together. When I add them together, I get back to this. Same thing. Minus 7 plus 7/15 plus 15. Now, the nice thing about this is that then we can move stuff around, okay, to solve the problem easier. Now, when you do this, it's very important that you pay attention to the sign that is in front of the number. And the one that matters most with right now is this one here, this 7. So I can say I have a 12, I have a positive 8/15, I have a negative 7, that the negative symbol or the subtraction symbol has to travel with the 7, okay? Then I have a positive 7/15 and a positive 15. I'm going to move these around because of that commutative property of addition. I'm going to move them around to where it's easier for me to solve. Okay? So we could say 12 minus 7, so right now I moved that here. Okay, so let's see. I'll use arrows so you can see where I'm pulling from. And then plus 15. Okay, aren't those easier to deal with together? And then I can throw the other ones on the back, the ones at the fractions. We can deal with those together, which, look at that. Don't you love when we see common denominators? Okay, so let's see, boop. Okay, so I just used the commutative property of addition to move the numbers around to where they're easier to deal with. Okay, now we can do this. What's 12 minus 7? 12 minus 7 is 5. Now, I always rewrite everything. It keeps me organized. It makes me confident in knowing I'm not forgetting anything. So even though all I did was one step, I'm still going to rewrite the whole thing. Okay, and hopefully that helps you recognize what we're doing also. Okay, next, 5 plus 15. Ooh, love that. That equals 20. It's a nice, easy number to work with. Okay, and if you're ready, if you feel like you can, okay, so I'll say that's 5 plus 15. Okay. Okay, if you're ready, we can do 8/15 plus 7/15, because that's a really nice number too. Well, they already have a common denominator. Okay, so I just need to add my numerators. Well, 8 plus 7 is 15. So we have 15/15 plus 20. Well, what's 15/15? There's a much easier way to deal with that. If you have 15 slices of pizza, out of 15 slices of pizza, you have one whole pizza. So 15/15 is equal to 1. 20 plus 1 is 21. There's your final answer. Okay, so that will help you a little bit with number 2 on the quick check as well. And otherwise, I will talk to you soon.